So we're gonna do Newton's laws of motion, yeah. So let's go through them. First law of motion is, if the forces on the body are balanced, there's no resultant force, it's zero, then it's at rest or it's at a constant speed. And we talked about that in our force diagrams video if you want to go and watch that. Second law of motion states that if a force acts on a body, a resultant force acts on a body, it will accelerate according to the equation F equals ma. Force equals mass times acceleration. Third law of motion says that the action force and the reaction force, remember the reaction force is the table, and for example the action force might be the gravity, are equal and opposite. Second law states if a resultant force acts on a body, it will accelerate for force equals mass times acceleration. This can be rearranged into all of these different types. Force equals mass times acceleration. Acceleration equals force divided by mass. And mass equals force divided by area. And the force is in newtons, the mass is in kilograms, okay, and the acceleration is in meters per second squared. But we'll go through those when we do some calculations. So here's our calculation, and we've got 500 newtons worth of drag. Okay, it weighs 4,000 kilos, it's 6,000 going forward. So we've got a resultant force of 6,000 going forward minus the 500 of the drag, because they're going in opposite directions. Okay, gives us a resultant force of 5,500. Then we take 5,500, which is the force, and divide it by 4,000, which is the mass. Okay, and we've got an acceleration of 1.375, which is 1.4 meters per second squared. Okay, so meters per second squared. Okay, so you've got to remember their units and got to know how to do the calculations. So let's do another one with a rocket. Okay, and if you're doing this in class, please ask your teacher to do as much projectile stuff and rockets and cars because it's fun. What is the force acting on the following vehicle? Okay, this is 12,000 kilos. Okay, so it's very heavy. Okay, and it's going at 20 meters per second squared. So that's an acceleration, that's a mass. So that's an acceleration, that's a mass. So that's 12,000 kilos times 20. You've got the meters per second, per second squared. You see it's just shown here as a divide. Okay, and you've got 240,000 newtons worth of force. Okay, imagine you could probably calculate that for the SpaceX launch and just look it up on the internet, how much was the weight and what is the acceleration, and you can calculate the force quite easy. Okay, let's go on to an air track. So an air track here pushes air out of all these little holes and stops the friction, so it's a frictionless surface. So we've got a cart with a mass of 100 grams, which is 0.1 grams, and the air track is there to reduce any friction. Now Newton's third law, okay, there's your air, okay, is object at rest stays at rest, okay. Now, also, the third law, okay, let's look at it here. So, finger pushes on the cart with 2 newtons to the right, and the cart pushes on the finger with a force of 2 newtons to the left. So the action force and the reaction force are equal and opposite. Okay, now, if that is the case, you can find the acceleration equals F equals ma. So we know the force is 2, okay? So that means if I push it, I'm pushing it with 2, I'm pushing it that way. So I'm pushing it this way, and it's 2 newtons, pushing in that direction. I know the mass of this is 0.1 grams, so I think the acceleration is going to be 20 meters per second squared. And here it goes at 20 meters per second squared. Okay, now the acceleration of the car is given by F equals ma. Okay, and we can also, if I just move that on a little bit further, it's quite cool, isn't it, moving along there. Okay, you can see that if an object is moving, it keeps moving at a constant speed in a straight line. So what I'm trying to say here is if I push this and there's no friction, so there's no friction because of all the air coming out these holes. If I push it, and theoretically this never ended, because there's no friction, this thing would just keep going and keep going and keep going at constant speed. I want to make that absolutely clear. We have applied 2 newtons here, okay? And that object, if there's no friction, to stop it, remember the friction with the surface would slow it down, okay? It would keep going. Now eventually, if it was on Earth, it would stop. And it would stop because of the air resistance eventually. Okay, but if we could do it theoretically with no air resistance and no friction, this object would just keep going, keep going, keep going at a constant speed. And you can see that if you have a look at any movies in space. Because if you think in space, you go dink like that, and the thing will just go on and on and on at a constant speed. Okay, because there's no resistance, because space is mainly empty. Okay, now that's our video on Newton's laws. The next one's going to be on friction and resistance and how to carry out an investigation.